This is SpaceTime Series 27, Episode 64, for broadcast on the 27th of May 2024. Coming up on SpaceTime, new research into how sunspots are formed, NASA and ESA to launch a joint mission searching for signs of life on Mars, and new weapons in the battle against space junk. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The spectacular solar storms, which shook the Earth earlier this month, may have originated closer to the Sun's surface than previously thought. A week of spectacular geomagnetic storms pummeled the Earth and created dazzling northern and southern auroral lights, the aurora borealis and aurora australis. The storms included some of the most powerful solar flares since 2005 and an overall intensity not seen since the infamous Halloween storms of October 2003. These geomagnetic storms are all part of the Sun's regular 11-year solar cycle. The current cycle, number 25, began in December 2019, when the Sun was extremely quiet with no visible sunspots, a period known as solar minima. Gradually, the Sun gets more and more violent as the number and size of sunspots increases, triggering prominences, coronal loops, solar flares, and coronal mass ejections. Sunspots are cooler regions on the Sun's surface that appear darker than surrounding areas. They're caused by magnetic field lines reaching out into space from inside the Sun and preventing some of the heat from within our local star from reaching the surface. Because the Sun isn't a solid object like the Earth, but rather a giant ball of plasma, different latitudes of the Sun rotate at different rates, causing the Sun's magnetic field lines to become tangled and twisted. Eventually, they snap and realign through a process called magnetic reconnection, and that generates powerful explosions, producing secondary phenomena such as eruptions of electromagnetic energy called solar flares and blasts containing billions of tons of coronal plasma and embedded magnetic field called coronal mass ejections. Now, scientists reporting in the journal Nature think they may have uncovered the possible origins of the solar dynamo which is driving all this volatile activity. We know the Earth's magnetic field is generated by our planet's solid inner and liquid outer metallic cores, acting as a geodynamo. But being a superheated plasma, the forces generating the Sun's magnetic field are very different. Now, one of the study's authors, Benjamin Brown from the University of Colorado Boulder, says scientists have been trying to understand sunspots ever since Galileo Galilei first observed them in 1612. That's well over 400 years ago. Brown says Galileo learnt a lot about them, including how they move across the Sun's surface, but he couldn't figure out where they came from. And astronomers have been struggling with that question ever since. The authors of our study, led by Geoffrey Vassell from the University of Edinburgh, have been examining the complex chemistry and physics in the Sun which produces these magnetic fields. In general, scientists agree that the solar dynamo begins in the Sun's convection zone, roughly a third of the way out from its core. There, plumes of hot charged plasma climb out towards the surface. While the Sun's magnetic field is mostly uniform, the churn of plasma through the Sun's convection zone warps and twists its magnetic fields. And this is the dynamo in progress. Back in the 1990s, scientists proposed that the Sun's dynamo emerged roughly 200,000 kilometers below the Sun's surface, a theory nicknamed the dynamo in the deep. One of the basic ideas for how to start a solar dynamo is that you need a region where there's a lot of plasma moving past other plasma and that the shearing motion between the two plasma streams converts kinetic energy into magnetic energy. The trouble is, theories suggesting the dynamo has a deep origin also predict solar features that astronomers have never observed, such as strong magnetic fields at high latitudes. We're not seeing that, and it struggles to explain the order which ultimately emerges from all this solar chaos. Instead, Vassell, Brown and colleagues are turning to a different phenomenon in physics called a magnetorotational instability. It's a sort of imbalance. It forms whenever magnetic fields interact with rotating plasmas, where those flows move faster as you go deeper. Brown says it's sort of like dance partners slinging each other around in a spin while holding arms. Scientists have already been examining how this phenomenon arises in the accretion disks of hot gas that circle black holes. And as you can imagine, its role in the Sun is even less clear. Now, in this current study, Vasil Brown and colleagues ran a series of calculations on a NASA supercomputer to try and study how such an instability could influence the Sun's activity. And unlike previous models, this new numerical simulation carefully examined the role of torsional oscillations, a cylindrical pattern of how gas and plasma flow within and around the Sun. As we mentioned earlier, because the Sun's not a solid object, it doesn't rotate as one body. Instead, its rotation varies with latitude. Now, just like the 11-year solar magnetic cycle, torsional oscillations also experience an 11-year cycle. And because the wave has the same period as the magnetic cycle, it's long been thought that these two phenomena may be linked. Now, the traditional deep theory of the solar magnetic field can't explain where these torsional oscillations come from. But an intriguing clue is that these torsional oscillations only appear near the surface of the Sun. The new hypothesis suggests that the magnetic cycle and the torsional oscillations are actually different manifestations of the same physical process. And the numerical simulations are showing that the new model provides a quantitative explanation for the properties already observed in the torsional oscillations. The model also explains how sunspots follow patterns in the Sun's magnetic activity, another detail missing from the original deep origin theory. And the authors discovered this process could easily whip up inside the Sun, forming the solar dynamo and explaining how the 11-year solar cycles start. The physics involved take place only in the outer 10% of the Sun, a paltry 20,000 kilometers from the surface. The solar dynamo, in other words, might be powerful, but it's also a little on the shallow side. This is SpaceTime. Still to come, NASA and ESA to launch a joint mission to search for signs of life on the red planet Mars, and a new weapon in the battle against space junk. All that and more still to come on SpaceTime. NASA and the European Space Agency have agreed to work on a new joint mission to search for signs of life on the red planet Mars. The new mission is slated for launch in 2028. It'll be based on Europe's existing ExoMars Rosalind Franklin rover mission, with NASA providing lightweight radioisotope heater units for the rover, as well as its propulsion system needed to land on Mars. Rosalind Franklin will be the first rover capable of drilling down to depths of over 2 meters, thereby allowing it to collect ice samples from deep under the surface, samples which up until now have been protected from surface radiation and extreme temperatures. If there is life on Mars, that's where it's likely to be found. The rover's primary science instrument will be the Mars Organic Molecule Analyzer, which will search for the building blocks of life in the Martian soil samples. Now, this Rosalind Franklin mission is separate from the long-proposed joint NASA-ESA sample return mission, which is designed to retrieve Mars samples collected by the Mars Perseverance rover in Jezero Crater and return them to Earth. That's a multi-rocket project, with a price tag now approaching over $11 billion US, and that's forced NASA to re-examine the proposals in order to find savings. This is SpaceTime. Still to come, new weapons in the battle against space junk, and later in the science report, grim warnings that there may be no known way to stop artificial intelligence from ultimately taking control. All that and more still to come on SpaceTime. Scientists are hoping to use hunter-killer satellites equipped with plasma guns to deal with space junk. Space debris orbiting the Earth is a major problem, with hundreds of disused and damaged spacecraft and, quite literally, millions of bits of space debris now orbiting the planet. And when the space junk collides with operational spacecraft, it causes serious damage and can even create more debris. It's a growing problem which is getting worse every year. Amplifying the problem are rogue nations like China, who have been shooting missiles to deliberately destroy disused spacecraft as part of military tests. The ultimate nightmare scenario is something called a Kessler syndrome, where some orbits simply become too dangerous to operate in. Now, there are lots of different proposals to try and clean up the worsening problem. Some involve spacecraft with nets, others involve laser beams being shot into space from the Earth. Since 2018, researchers from the Australian National University and Japan's Tohoku University have been developing a plan to use satellites to seek out and move spacecraft using beams of ionised gas to push disused satellites and rocket bodies down into lower orbits where atmospheric drag will eventually cause them to undergo orbital decay and burn up during re-entry. One of the scientists involved in the project is Rod Boswell from the ANU's Research School of Physics and Engineering. He says early tests have shown that you can push plasma out one end of a satellite to thrust it forward towards a piece of space junk and then push it out the other end to send that junk in the right direction. Boswell says if you can throw gas out as a plasma or charged gas, you can throw it out very quickly, thereby making much better use of the fuel. You're throwing out less of it because it's thrown out faster. The key is lowering the space junk's orbit. A piece of space junk will naturally decay within around 2 years if its orbit is below 500 kilometres above the Earth's surface. That's because the atmosphere is still dense enough at that altitude to cause a limited but definite amount of friction, and that causes the junk to gradually get slower and lower. Space junk's now regarded as such a major problem that most space agencies now require spacecraft launched from their soils to include some system to deorbit them once they're no longer in use. However, some nations, such as China, are ignoring this convention. Boswell and colleagues have been using a space simulation facility at Tohoku University in order to test their proposals. Once in orbit, the so-called Shepherd system would have a main plasma engine thrusting it towards the space junk, as well as smaller thrusters to more accurately maneuver it directly towards its target. Target acquisition would initially be done from the ground, with the Shepherd system taking over once the target's in range.
Commonly, if you have a thruster, you push material out of one end of it and your thruster moves in the other direction. What we've done by using a rather clever plasma technique is to produce a thruster with two ends. It squirts out the front and it squirts out the back, and we can control that. So we can do a few things with this. We can move the thruster forward, or we can move the thruster back, or we can bring the satellite containing the thruster close to a piece of space debris and have both thrusters working at the same time, so the thruster stays in the same place, but one of the thruster blows on the debris and moves it away. So if you have just a thruster blowing on the debris and moves it away, the thruster's going to move away too, because of Newton. For all actions, there's an equal and opposite reaction. So we have a thrust with an outlet in the front and an outlet in the back, and it can push space debris around in that manner. That's the basis of what we've done.
The idea is making sure there's enough fuel on that thruster to be working for a long, long time. Otherwise it gets really expensive if you've got to keep putting things up there.
It's pretty expensive to put things up there anyway. It's more expensive to get them down. Yes, so that's why we use electric propulsion, because normal propulsion throws things out at a certain speed, but with electric propulsion, you use charged particles in a plasma and throw it out much faster. So if you can throw it out 10 times faster, you only need to throw out 10 times less.
With these ion propulsion systems in the past, we've seen very slow acceleration in those for satellites. In other words, they take much longer to take effect than a normal chemical engine thruster. Is this still going to be a problem with this type of proposal?
It's very same. Do you know the story of the old bull and the young bull?
Tell me about it.
Well, there's an old bull at the top of a hill and a bunch of cows down below, and then there's a whole bunch of young bulls around the old bull. And one day the farmer left the gate open, and one of the young bulls says, "Let's go down and say hello to the cows. Let's rush down and whoa." And the old bull said, "No, let's walk down and say hello to all of them." The game is softly, softly, catchy monkey. So if you can keep the acceleration going slowly but for a longer time, you can have a lot more control and power than just thrusting off suddenly.
And so the idea is, you've talked about both moving them up into higher orbits and also moving them down into lower ones. I take it moving down is really the idea. You got to get them below 500 Ks so that the Earth's atmosphere will do the rest through atmospheric drag.
That's very true. That would be the primary thing for something around about 500-600 kilometres. If you're at 36,000 kilometres, which is where some of these very large telecommunications satellites are, you can't do that. You have to push them up. They go into a graveyard orbit, and we're working on that as well.
Luckily, luckily right now, I think it's generally, I don't know if it's legally mandated, but there's an agreement that geostationary satellites should retain enough fuel to move into this graveyard orbit.
Oh, well, it's regarded as very naughty if you don't do that, and people get very cross because you only hire the slot for 5 or 10 years, and then you have to get out of it and let the new satellite come in. I mean, they're sold. The slots, which are 2 degrees wide, I think, so there's 180 of them, are given to countries around the world to own, and they are then on-sold to telecommunications companies. So the space is sold for a certain time. You have to get the satellite with the thruster on it, but it also has to have lots of other small micro thrusters to be able to position itself relative to the space junk. On top of that, the space junk, you know its orbit fairly accurately within X kilometres for a position. But the satellite then will have to interrogate space junk, so it'd have to have some active radar and AI on board to be able to hunt it down. So it's really a hunter-killer system. It needs to know what it's looking for. For the micro thrusters, we're looking at electrothermal thrusters. We use the radio frequency to produce a plasma, such as you get in light globes, and then that is used to heat a gas. So the gas comes out much hotter than it went in, and that's how we would use just to push the satellite around to control its position. Once again, the whole aim is to save propellant, as you mentioned before.
What size targets are you aiming at? I guess that depends on the size of the hunter-killer satellite you develop, doesn't it?
That's precisely the case, yes. So anything, you'd have to see it with a radar, right? So it's going to have to be in 0.5 metre or so, I would say, and greater. Smaller than that is going to be extremely difficult to see because small objects will just refract or deflect the radar probing waves.
One of the big concerns isn't just the decent-sized pieces of space junk out there that can be tracked, but the small bits of debris, those that are a result of cascades in space, where one piece of space junk slammed into another piece of space junk. We've seen that with Iridium satellites and Russian spacecraft, and of course the Chinese did a really great job with a disused meteorological satellite they decided to blow up in space. How do you get rid of stuff like that?
I think if you're aiming for something and you have large amounts of power, then you might be able to get close-ish to hit it. Trying to do it when you're in orbit is a damn sight different, and it's actually really unusual for that to happen. And I'd say anything smaller than a pack of cards or something like that is the best solution is prayer.
We've seen a European test of a new space debris recovery system. They're using a net. They'll also be using a harpoon and finally grab a piece of space junk and drag it into the Earth's atmosphere with them.
Then that's a suicide mission. You get rid of the thing you sent up to get rid of the piece of space junk. You then have to write that off on how much it's going to cost you and how much it's going to save you.
That's one proposal. Here in Australia, a place in Queanbeyan have been looking at using laser beams, not just to track space junk, but also to heat them up and slow them down a little bit as well. Big problem with the idea of using a laser beam from the ground. A lot of countries are uncomfortable with that because they're concerned that anything that can be used to move space junk can also be used to destroy an operational satellite at a time of war.
I think it'd be easier to blind an operational satellite in a time of war than trying to move it, to be blunt. These puppies are moving at 7 kilometres a second. You're hitting them with a few photons. You'd have to do a lot of work to do that, but you can do a lot more damage trying to knock off specific bits of electronics, I think. However, okay. I'm not going to say how to do that.
That's Professor Rod Boswell from the Australian National University. And this is Space Time. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study warns there is no known way to stop artificial intelligence from taking control if they exceed human abilities and pose a risk to humanity. The disturbing warning, reported in the journal Science, follows ongoing warnings about the rapid development of AI, which has developed the ability to lie and deliberately manipulate and delude humans in order to achieve a specific aim. The researchers say there's currently no consensus on how to manage the risks. They've recommended directions for proactive and adaptive governance to mitigate the risks, calling on big tech and public funders to invest more in risk assessment and mitigation, and encourage global legal institutions and governments to enforce specific standards to prevent AI misuse. They say advanced AI systems now pose grave risks to society, such as amplifying social injustice, eroding social stability, enabling cyber criminals, facilitating automated warfare, customized mass manipulation, and pervasive surveillance. And perhaps the biggest risk of all is losing control of autonomous AIs altogether.
Just what do you think you're doing, Dave?
A new study claims a lack of sleep in childhood could increase one's risk of psychosis in early adulthood. The findings, reported in the Journal of the American Medical Association, are based on a study involving 12,000 kids and almost 4,000 young adults. Researchers found a definite link between persistent shorter sleep in childhood and psychosis in young adulthood. Sleep duration was collected at multiple intervals between 6 months and 7 years of age, and then at age 24, participants were checked for any past psychotic experiences or disorders. The researchers found that people who had persistently short sleep durations during childhood had a higher risk of psychosis by the time they were 24. A new study has shown that teens who vape frequently have twice as much uranium and 30% more lead in their urine than teens who only vape occasionally. The findings, reported in the journal Tobacco Control, also showed high uranium levels in teens who preferred sweet vape flavours over menthol ones. The study canvassed some 200 teens who vape but didn't smoke, which makes it less likely that these toxic chemicals were coming from tobacco. A new study claims Australian followers of TikTok health and wellness advice are among the world's most gullible people. Tim Mendham from Australian Skeptics says, while the research from the Dublin City University has many problems and isn't very reliable, it does highlight the stupidity of the sort of phony health and pseudoscientific medical advice available on this highly popular Chinese social media app.
This is a horrible story from two different points of view. One is that it's a survey that I find a bit dodgy, and the other thing is that people are following advice on TikTok. It used to be Dr. Google, now it's Dr. TikTok or Professor TikTok, Professor Tick, and there are a lot of people out there, influencers as they like to call themselves, who are proposing all sorts of medical treatments, and that's a problem. It's unreliable. In fact, someone did a survey of a medical supplement company, did a survey of people's belief in TikTok, and also with the university in Dublin, they looked at thousands and tens of thousands of TikTok videos to try and see how much is accurate. Now, as far as the survey goes of people, it's a bit hard to find out exactly what the survey was. I found out some information. It was about 2,000 millennials and Gen Z, people in US, Canada, UK, Australia. I don't know if it was a online survey or if it was a phone survey or whatever. Online surveys are notoriously unreliable because anyone can come in and sort of give an answer to, and only those with an interest will give you an answer, which tends to boost the result a bit. And the result here, to me, seemed very boosted. The suggestion was that Australians are more likely to follow the advice on TikTok, and these researchers found that 9 out of 10 Australians have taken nutrition advice from the social media platform more than once. I think that's, well, there's a word for that to me. I don't think I can use it on a family podcast such as yours. I would suggest that 9 out of 10 Australians is very high, inordinately high. I would say that I don't know how many of these 2,000 millennials were in Australia. We don't know if they volunteered their own information, so there might have been people keen on TikTok and TikTok health advice. And say 9 out of 10 Australians have taken nutrition advice, not just looked at, but actually taken the advice. 2 in 5 Australians are trusting the social media platform for nutrition and wellness advice, compared with 39% in the UK and 35% in the US and 25% in Canada. I don't know how many people they got in Australia. Was it 10? And 9 of them said they followed the advice. Was it 100? It's hard to say. But there's a lot of advice out there.
It makes you wonder where the survey was. For a start, you're dealing with people who are on TikTok all the time. So it's a young audience who often don't know any better. So they're not getting their news from a reliable source anyway. So, 9 out of 10 TikTok users follow this advice. It says a lot about the people who are on TikTok. That's what it does.
It does. Don't forget, it's 9 out of 10 young TikTok users, right? That does not make 9 out of 10 Australians, generally.
No, that's 90% just an extrapolation they're drawing from that because it's...
And it's a wrong extrapolation, and hey-ho, we're in a survey land in which sort of you've got to be careful of the extrapolations you make. Saying that a headline says that Australians are most gullible for TikTok health advice means this little bunch of a small cohort or a select cohort of TikTok users, presumably, have a high percentage of people who follow the advice in these things. So you really got to take all this with about a pound of salt, that all the results of these sort of things. Anyway, they suggest that when they look at the actual videos of this TikTok advice, that a lot of it is rubbish, certainly either totally unfounded or potentially dangerous. Some of the things they suggest might not be the thing to do. And this study, I should say, with the Dublin City University, found that, quote, a meagre 2.1% of the analysed nutrition content was accurate when compared with general public health guidelines. That's 1 in 50, might have some benefit, whereas the rest don't do it. This might be eating raw carrots for rebalancing your hormones, detoxes for weight loss.
You can't rebalance your hormones. It doesn't work
Funny
that
thing.
way.
Funny thing. Detoxes for weight loss. The body detoxes itself all the time, constantly. That's what your body does. Foods that burn stomach fat, they don't exist, right? You're not going to get them.
I wish they did.
I know. Don't we? All of those have a little sort of pudginess. Would love it if that was the easy way out. Liquid cleanse. You have to be very careful of what's in a liquid to cleansing you. Again, lettuce water helps you fall asleep. No, it doesn't. Actually, it might keep you awake. All sorts of things that are put in these tens of thousands of videos that are by totally, largely unqualified people who look nice, perhaps as influencers on social media, and they look all healthy in their little exercise gear, etc. But the advice is by and large totally amateurish and wrong and dangerous. But the suggestion that so many people are following TikTok health nutrition, actually applying it, might also be a bit as dodgy as some of the cures that are being put forward.
That's Tim Endham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.